Okay.
One moment, please.
Okay, I fixed it. All right. Since we know the shorthand derivative, the power rule, our best friend, we now get into some more rules for derivatives. We have the product rule and the quotient rule. Okay, so the product rule says if f and b are both differentiable, then the derivative of f of x times g of x is going to equal the derivative of f of x times g of x plus the derivative of g of x times f of x, or, put it simply, f prime g plus g prime f. So for the first four examples, we're going to do product rule. All right. So the way to do product rule is label your function f and label your function g. So here's f, and there's g. So what I'm gonna do now is say f equals 3x plus 2, and g equals 4x minus 5. Now, to follow the product rule formula, we need to know the derivative of f and the derivative of g. So that's what I'm going to do next. I'm going to say f prime, the derivative, and the derivative of 3x is 3. The derivative of 2 is 0. So all we are left with is 3. And then we're going to do the same for g. G prime, the derivative of function g. The derivative of 4x is 4, and the derivative of negative 5 is 0. We are now ready to apply the product rule. So remember that we are taking the derivative of g of x, so that's how we'll start out. We're going to say g prime of x is equal to, and here is how we'll do the product rule. The product rule is f prime times g. So I say f prime times g, and I write it down. 3 times 4x minus 5 plus g prime times f. 4 times 3x plus 2. The product rule is done. The derivative is done. The calculus is done. Rest is cleanup, which is purely algebraic. Distribute the 3, distribute the 4, and simplify. We'll get 12x minus 15 plus 12x plus 8, which will give me 24x minus 7. That's it. That's the product rule. Now, what's to stop you from foiling this out and taking the derivative? Nothing. If you FOIL this out, you'll get 6x squared minus 15 plus 8 minus 7x minus 10. What is the derivative? So if I said d over dx of 6x squared minus 7x minus 10. Let me actually make that d over dx. And if I said, not 6x, ugh, it's the end of the night. It's my last recording, fourth one in a row. That's tiring. This should be 12x squared. There we go. Okay. Then I say, what is the derivative of 12x squared? You get 24x. What is the derivative of negative 7x? You get negative 7. What's the derivative of negative 10? 0. Is this the same as that? And the answer is yes. But that wasn't the exercise, was it? The exercise is to use product rule. But just know that that is another option to check your work. Okay. I'll take that. Okay, product rule again. All right, label your functions. Here's f. There's g. F is 2x squared. G is 3x to the fourth minus 2. F prime is 4x. G prime is 12x cubed. Okay, then we are taking the derivative of f of x. So we'll start with f prime of x, and you'll get f prime g. 4x times 3x to the fourth minus 2 plus g prime f. 12x cubed times 2x squared. Product rule's done. Derivative's done. Calculus done. Algebra from here on. Is he insane? Maybe. Okay. 12x to the fifth minus 8x plus 24x to the fifth. One final cleanup, 36x to the fifth minus 8x. Done. And just like the one above it, you can distribute the 2x squared in to check your work. But we are trying product rule out. Okay, again. X squared is f. Sine x is g. F is x squared. G is the sine of x. F prime is 2x. G prime is cosine x. The derivative of x squared, 2x. The derivative of sine, cosine x. We're taking the derivative of y, so we will write, let me make room, y prime. Follow your product rule. F prime g, 2x sine x plus g prime f. And that's cosine x times x squared, but I'll just write it as x squared cosine x. Okay. If we want to be really neat and picky, what is your greatest common factor? Just an x, right? So you'd have x times 2 times the sine of x plus x cosine x. There we go. All right. Nothing to it. I told you. Calculus is easy until 2.7. Okay. Again. Sine is f. Cosine is g. F is sine theta. G is cosine theta. F prime is cosine theta. G prime is negative sine theta. We're taking the derivative of y with respect to theta. So I'll play around with notation again. We'll say dy over d theta and follow your product rule. Cosine times cosine. Cosine squared theta. Plus negative sine theta times sine theta. So that'll actually be negative sine squared theta. So this will be minus sine squared theta. Okay. Well, derivative's done, product rule's done, calculus is done. The rest is cleanup. And you're wondering, how can we clean this up? Well, I hope you remember your trig identities. What trig identity does this belong to? And hint, hint, it is a double angle. So remember that cosine 2 theta is also cosine squared theta minus sine squared theta, which means we can put our final answer as dy over d theta of cosine 2 theta. And that, my friends, is product rule. Easy process to follow. Follow the formula, know your derivatives, know your identities. You will be just fine. Oh, and of course, know your algebra. That part, you may not be fine on. Okay, next is the quotient rule. D over dx of f of x over g of x is equivalent to the derivative of f of x times g of x minus the derivative of g of x times f of x over g of x squared. Or f prime of x times g of x minus g prime of x times f of x over g of x squared. Or the simpler format is f prime g minus g prime f over g squared. Follow the formula and you will be just fine. We're going to do the exact same thing we did for the product rule. Label your f, label your g, take the derivatives, follow the formula. So here we go, number 5. All right, numerator is going to be f. Denominator is going to be g. F is x squared plus x minus 2. G is x cubed plus 6. Derivatives, you should get 2x plus 1 and 3x squared. All right, we're taking the derivative of y. So I'll play around with notation again, and I'll write dy over dx. Okay, follow the formula. F prime g. 2x plus 1 times x cubed plus 6 minus g prime f. 3x squared times x squared plus x minus 2 all over the original denominator squared. Okay, and again, derivative is done. Quotient rule formula done. Calculus done. Rest is algebra. FOIL, distribute, combine like terms. FOIL, distribute, combine like terms. It's a good song. Get it burnt in your head. All right, so I'll get 2x to the 4th plus 12x plus x cubed plus 6 minus 3x to the 4th minus 3x cubed plus 6x squared over x cubed plus 6 squared. All right, still combining. I have 2x to the 4th and negative 3x to the 4th. So that's negative x to the 4th. Use that, use that. I then have x cubed minus 3x cubed. So negative 2x cubed, x cubed minus 3x cubed. And then, who's the next one? 6x squared plus 6x squared, use that. Plus 12x plus 6. All over x cubed plus 6 squared. And there's not much else we can do. That one's done. And that's how you do quotient rule. Follow the formula, we'll be okay. Next one, same thing. Numerator, f, denominator, g. F is x squared plus 1. G is 2x minus 3. Derivative time. F prime is 2x. G prime is 2. We're taking the derivative of f of x. So we'll say f prime of x equal to, and follow your formula. F prime g, 2x times 2x minus 3 minus g prime f. 2 times x squared plus 1 over the original denominator squared. Calculus, derivative, quotient rule, done. Algebra on. Four x squared minus 6x minus 2x squared minus 2 over 2x minus 3 squared combine like terms. 4x squared minus 2x squared gives me 2x squared. And then all that's left is 2x squared minus 6x minus 2 over 2x minus 3 squared. Okay. One more chance to simplify. We see that in the numerator, you can factor out a 2. So you get 2 times x squared minus 3x minus 1 over 2x minus 3 squared. Nothing else to do from there. Okay. Still going. Next is the derivative of tangent. Well, if we're using quotient rule, this means we should rewrite tangent as its quotient identity. Now you see where trig identities are coming back to haunt you. So that's why we should never forget them, especially when you get to Cal 2. So we will rewrite this as y equals sine x over cosine x. And now the numerator is f, the denominator is g. F is sine of x. G is the cosine of x. F prime is cosine x. G prime, negative sine of x. We are taking the derivative of y, so we'll keep it simple this time and just say y prime. Follow your quotient rule formula. F prime g, cosine times cosine. Cosine squared x. Minus negative sine times sine is negative sine squared. But this negative is waiting out here already. So negative and negative will make positive. So you'll get sine squared x over the original denominator of cosine x squared. Okay. Now I know you see it. What is cosine squared plus sine squared? Cosine squared plus sine squared is that magical number of 1. So we end up with y prime equals 1 over cosine squared x. But now, what identity is 1 over cosine squared? We're almost done. 1 over cosine is secant. So 1 over cosine squared must be secant squared x. So what we can take away from this is a derivative identity. The derivative of tangent is secant squared. What? Done by derivatives. All right. Look at that. That's quotient rule. Last page. Here is a lovely box for your reference of trig derivative identities. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent, we just proved, is secant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent. And derivative of cotangent is negative cosecant squared. So our last problem is prove that the derivative of cosecant is negative cosecant cotangent. So let's do it. All right. So d over dx of cosecant x, well, we have to use cosecant's identity. And cosecant's identity is 1 over the sine of x, which means we now have a quotient, which means we can now apply quotient rule, where the numerator is f and the denominator is g. So f is 1. G is the sine of x. The derivative of 1 is 0. the derivative of sine is cosine. And now, since we are proving this, we are going to say d over dx of cosecant x is, follow your quotient rule formula now, f prime times g, 0 times sine is 0, minus g prime times f, cosine times 1, cosine. Over the original denominator of sine squared. Okay. Now we have negative cosine over sine squared x. And how can we make negative cosine over sine squared look like negative cosecant cotangent x? Well, that goes with how many sines do I have in the denominator? I have 2 sines in the denominator, hence it's sine squared, which means I can split it into how many fractions? 2. So if I split this into negative cosine over sine x times 1 over sine x, is that not the same thing? We haven't done anything wrong. The only thing we did is split up sine squared. And now, by identities, what does negative cosine over sine become? That becomes negative cotangent x. What does 1 over sine become? That becomes cosecant x, which means we get our answer of negative cotangent x times cosecant x. And therefore, proven. And it doesn't matter how I write it. Negative cotangent cosecant x is exactly the same as negative cosecant cotangent x. Proven. All right. That is product rule. That is quotient rule. Follow the formula. You'll be okay. The only challenging part is probably going to be the algebraic cleanup. And that's okay. The more algebra, the better. But that's it.